Hello, today we have the Nacelle wind turbine training system by Festo Didactic. This is a training unit designed for training the wind turbine technician. So it's especially designed for training. It comes with all the courseware, the tools for exercises, but today we'll look at the machine itself. So, the machine comes in 4 different variants. We have typically the 120 volt 60 Hertz. We've got the 230 volts 50 Hertz. And then we have the variants with the grid tie. And when you add on this feature, you then need a 3-phase supply. So then it becomes 208 volt 3-phase 60 Hertz and 400 volt 3-phase 50 Hertz. So those are the 4 variants. Being a big unit, of course, we need to first look at safety. Just to mention that we have here e-stops that are all around the machine, accessible everywhere. They are emergency interlocks with the opening of the doors that you see here. This will bring an alarm on the system and will shut down the machine in emergency mode. So speaking about safety, these machines are up to the general standards that we have. So for the 120 volts, we have the CSA certification. For the 230 volts, we've got the CE certification. So this is up to most demanding standards. We have the UL for the US as well. So it's really made for training safety. What we have here, the main elements, if I open the gate, you have here the wind simulation. So first thing first, there's no wind around here. So what we do, we simulate wind conditions. So the whole machine is driven by a motor and chain that are activated according to the input of the student. So we can input wind parameter, set different conditions, and the machine will react to these conditions. So here the main shaft with the big pillow blocks. This is the main part of the internal of the nacelle. For speed adaptation, we have here a gearbox. So for those machines that runs at 20-25 RPM, the blades at that speed is not enough. So there's a gearbox to bring the generator to speed. So we're looking at 1500 RPM for the 50 Hertz and 1800 for the 60 Hertz. The whole machine is mounted, of course, on the mast, and we simulate the mast. We're here, the tower, and we have the yaw system. In this case, we have this big slewing ring that turns the nacelle to keep it in the wind. Okay. Also, to run the machine, there is this hydraulic power pack. So the hydraulic controls the brake. So you have a main braking system. On the yaw system, you have also a parking brake to make sure that the nacelle keeps in the wind. And all the necessarily equipment is built in this compact custom-made block. Okay. For the control of the system, we have here the HMI that is linked inside this electrical cabinet, and this controls a PLC, which all signals of sensors and valve and outputs are controlled from there, and you can operate the machine from the HMI. Now here on the side, we have two more elements, which is the grid tie power generator. So the whole system is based on this synchronizer and load capacitors, okay? So in this case, this is available, as I said, in 120 volts and 230 volts. It's the same controller that is configurable to synchronize at 50 hertz or 60 hertz, okay? So if you don't have the optional grid tie power generator, this is a blank facade only. Here is the control panel, okay? Itself, it holds the PLC that controls the whole machine, all the I/Os, the terminal blocks. There's those contactors for the motors, and we have here 3 variable speed motor controllers, okay? So that takes care of the control part. And the PLC is linked to this HMI. Also, provision are taken to network the pitch hubs that we have. So the nacelle is one part of the system. If you want a complete wind turbine system, then we have another unit, which is the variable pitch controllers. So we have one trainer is the hydraulic pitch hub, and we have also the electric control of the pitch. So these are readily made to be synchronized in a network manner with the nacelle. So that's it. On top here, you have the wind element. So the nacelle works with sensors. So you have the wind vane that tells you the wind speed and wind direction, okay? In this case, as I said at the beginning, there's no wind, so we simulate these sensors. So we put a small motor and we move these, but the sensor will send a signal directly to the PLC. So we simulate the motion, we drive this animal with a small motor, and we take the reading directly from the sensor. Now to the HMI. The HMI, we have now here a nice widescreen 19-inch Siemens HMI mounted on this nice swivel arm that allows you to operate around the machine. And we have the main menu where we show the main parameter of the machine. So you have the blade angle is simulated in this case of the hub. You have a grid connection status, the hydraulic status. You have also the speed of the machine here, gearbox output speed, temperature, vibration, etc. You have here the yaw, which is the tower movement, so you can see the actual angle, if it's moving, yes or no. You have here the wind simulation window, where you actually see the required wind and the actual wind. And then you have the speed and direction here. The generator status at this place, it tells you if it's generating or not. And here you have the start the trainer. In this case, the trainer is ready to run. You have another menu for manual operation. So you can here control individually elements of the machine without having the whole machine running. You could turn the rotor, you can set and release the brakes. Same thing for the yaw, you can control the position, you can move it, you can jog it, etc. Another screen is this histogram where you can display the yaw position, the required versus the actual. You could show the generator speed and what is the power generated. You have also the rotor and different blade angles and wind speed, so you can manage to see what's going on and how the machine reacts to the parameters. Okay. After that, you have the alarm page. So here you have the history of the alarm on the machine. You have the current status of the alarm, which could be activated or acknowledged or any else. And then here you can reset if there would be any active alarm. You have also here a service menu where you can set parameters. So the units, if you want the international system or the SAE. In this case, you can select language. 4 languages are there already, but you can enter your own if needed. You have the choice of the units, metric or SAE, and you have the trainer status as well. Here you have the main menu where you set the wind condition. So the whole machine is based on wind simulation. There's no actual wind. So here we will set the wind condition, wind parameter. So each step you can set a duration, a direction, and a speed. So in this case, we set for 30 seconds these condition. I can activate a second step, which has different parameters, and so on. I can put speed that are too high and too low for power generation, and you have up to 10 speed simulation. You then start the simulation with these button here. Finally, one last menu here. We have fault insertion. So the fault insertion asks you for your password. So once the password, which is known only by the teacher, hopefully, the teacher can set a few faults for troubleshooting exercises. So back to the main menu. Okay. Now I have reset my emergency stop. I have closed all of the doors. All the interlocks are set. So now it tells me, yes, the system status is okay, would be ready to start. So I will now start to operate the machine. So just back to the wind simulation. Here I have set up 2 steps, okay. Small wind values, okay, nothing excessive, and we could elaborate more on this later on. So it tells me trainer control, ready to start. So if I press here, you see that my wind simulation now has started. You see the instruments with the speed and the direction that I've set with my parameters. So now the pressure will build up, the machine will react, and slowly you will see the trainer will start. On the main screen, you can see wind direction. In this case right now, the set direction and the actual direction are superposed. So we are aiming at the wind. So this is great. You will see when the step changes the parameter, you will see here a red arrow and the blue arrow following. The machine is ready to be started. The hydraulic system is building up. And now we're simulating the pitch, and the machine is in front of the wind. So it's slowly picking up speed. As you can see, it accelerates at a small rate just to mimic an actual machine. On this screen, you see the rotor speed, 1,000, 1,200, 1300. And when you reach the threshold speed that we have set to synchronize, you now see the generator in green now is picking up energy to the grid. So conditions are met. We are now in the active step number 2 with the wind condition. And then you see now the wind condition change. Okay. My speed is constant. And it tells me connection to the grid is established. So I'm outputting some power to the grid right now. When my wind condition change in a few moments, you can see here the yaw condition is at the right position. The yaw can turn a few complete turns, but there is a twist sensor. So at one point you can, whether manually or automatically, unwind the cables. So you see now the wind condition changes more or less, and the synchronization is kept all the time. And here we simulate the pitch of the blades according to wind condition. You actually can see that the pitch will change to maintain synchronization. You see here the correction coming here. So all this can be done in a classroom environment. Of course, it's a big machine, some noise, but not so bad. We can live with this. And you can hear the hydraulic pump going in and out to maintain a working pressure of the system. Now, if I look at the trend, here you can see wind direction, the required, and the actual position. So as they are changed, you will see a small delay in the correction, and once the correction is made, the two lines superpose. If I change to the next screen, in this case, this is the RPM of the machine, which is maintained, and this is the wind speed. So you can see that we maintain the speed while the wind speed is changing. Power, it's 100%. Well, the line is at top here. Here you can see the simulated blade angle. So on the hub, you have angles that change according to the wind. So here you have the wind speed and the blade angle. So they should follow approximately the same look. To keep the nacelle in front of the wind, if we wait here, you will see the tower that will turn, just to simulate that the nacelle is turning according to wind conditions. All right, so now that the student has an alarm, he has to work the machine to find out the problem. So the troubleshooting is all explained in the courseware. He needs to follow the step, look at what the alarm is, and then he has to find the problem, and then he may reset and say, okay, this is the problem. Then the machine, now the status is okay. He may try to restart the machine, and if he has done the proper maintenance, then it will restart like this. So very easy. Once you have done some condition, you can go back to the wind simulation and say, okay, what happens if the wind is not strong enough? So I'll put an extra step here, a third step, and I'll set the speed of the wind lower than what is needed for power generation. Okay, so now this is set. We have now 3 steps, 3 wind condition. Wind speed 20 meters second, 15 meters second. These are good condition. And I've put this third step with a very low wind condition, 4 meters second. And what you see now, okay, we can set this one start, okay. Main menu, okay. Now, I have an alarm. Okay, so if the student has done his work, then the teacher can go back into the fault insertion, remove the fault, and say, okay, now you've done your work. You can go back to the alarm and try to reset. Okay, it acknowledge, then we can restart the machine. And there you go. Machine is ready to start. Now we can look at the new wind condition that we have. You see the nacelle now needs to turn. Okay. Get in the wind. Get up to speed. And when we come up to the proper speed, generator will start to get the power. So now we've got the power on to the grid. And we'll get to the third step where I've put very low speed condition for the wind so that the machine will not be able to supply power. And now you see the wind is going slower and slower. And cannot keep up to speed. So the generator falls off. All right, continuing on the training facilities, the actual nacelle comes with the complete electrical schematic for the student to do the troubleshooting exercise. We've got all the tools to do the maintenance and the dismantling of elements included in the exercises. And last but not least, we have a complete workbook with all explanation and what are the steps for the manipulation and the exercises. This manual this courseware is also available as a workbook, but also available on our ELIX training platform. Finally, in conclusion, if you need more information, you can visit our website. You can contact our sales representative, and we may set up a train the trainer session so that you can speed up your learning curve on the operation of the machine. So thank you very much, and see you soon.